And happy Monday. Oh my, what was that? I am going to pause. All that excitement, it was a shampoo bottle fell over in the shower. Well, it just was awfully loud. I thought, did the world cave in? But anyway, sorry about that. Here we go. So the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. I guess if the worst thing that happens to me today is the shampoo falls over, I'm doing well for a Monday. All right, so today we're going to wrap up the chapter with section 9.5. Tonight's homework will be 9.5 in the chapter review. Tomorrow we'll review. Wednesday, there'll be no class meeting. We'll just take the test. And again, it'll be due by Wednesday night at 11:59 p.m. So with that, let's go on to take a look at section 9.5. All right, so what we're going to do in this section is we're going to solve radical equations. We're going to have an equation that has like a square root or a cube root or a fourth root, and we're going to go in and solve the equations. Okay, now let's see here. Let's take one. This says the square root of x minus 10 equals 1. Just like solving absolute value equations, with a radical equation, if there's only one radical in the equation, we want to isolate that radical from everything else before we proceed. Now, in this case, the radical term is already isolated. So what we're going to do next, since it's a square root, we're going to square both sides of the equation. On the left side of the equation, the square root of x minus 10, the quantity squared, is x minus 10, because the square gets rid of the square root. And on the right side, 1 squared is 1. So now we have x minus 10 equals 1. We'll add 10 to both sides of the equation, x equals 11. Now, in the process of solving a radical equation where you do something to both sides of the equation like this, sometimes you create solutions that don't check when you plug them back in. Those are called extraneous solutions, and you'll see those referred to in WebAssign. If a solution is produced, but it doesn't work, that's known as an extraneous solution. If a solution is produced and it does work, then it's a solution. All right, so if x is 11, what do we get here? We get the square root of 11 minus 10 equals 1. The square root of 1 equals 1. 1 equals 1, it checks. So this solution is correct, it checks. Any questions about this example? All right, let's take a look at another one. The square root of the quantity 6x plus 1 equals 5. Once again, we already have the radical term isolated. It's a square root, so we will square both sides of the equation. On the left side, the square root of the square root of 6x plus 1, the quantity squared, gives us 6x plus 1. On the right side, 5 squared is 25. So we get 6x plus 1 equals 25. Subtracting 1 from both sides of the equation, 6x is 24. Dividing both sides by 6, x equals 4. Let's check our work. The square root of 6 times 4 plus 1 equals 5. The square root of 24 plus 1 equals 5. The square root of 25 equals 5. 5 equals 5. It checks. The solution, x equals 4, is correct. We okay with that? All right, let's take a look at another example. Square root of 1/2 x plus 3 equals 6. Once again, the radical has been isolated and it's a square root. Oops. So we will square both sides. On the left, we get 1/2 x plus 3. On the right, 6 squared is 36. We'll subtract 3 from both sides. 1/2 x equals 33. We'll multiply both sides by 2 to clear the fraction. X equals 66. And then we'll check our work. So we have the square root of 1/2 times 66 plus 3 equals 6. 66 times 1/2 is 33. 33 plus 3, the square root, equals 6. Square root of 36 equals 6. 6 equals 6. The solution checks. All right, now let's take a look at the following equation. The square root of the quantity 2a minus 3 plus 3, a separate term outside of the radical, equals a. Well, here, to isolate the radical term, we're going to need to subtract 3 from both sides of the equation first. Okay, so far? So now we're going to square both sides of the equation. On the left side of the equation, we get 2a minus 3. On the right side of the equation, we get a minus 3 times a minus 3, which is a squared minus 3a plus 9, which is a squared minus 6a plus 9, foiling this all together. All right, I'll pause there for a moment while you get caught up. We good to go on?
Yes.
Okay. Well, this is a second degree equation. So I'm going to solve it, hopefully by factoring. And so what I'm going to do is I'm going to put everything on the right side set equal to 0 on the left side. So I'm going to subtract 2a and add 3 to both sides of the equation. So I get 0 equals a squared minus 8a plus 12. And that factors into minus 2 minus 6. Minus 2 times minus 6 is positive 12. And then we get minus 6a minus 2a in the middle. Okay. So then a minus 6 equals 0 and a minus 2 equals 0. If a minus 6 equals 0, adding 6 to both sides of the equation, we get a is 6. If a minus 2 equals 0, adding 2 to both sides of the equation, we get a equals 2. Well, I don't really have a lot of room to check my work here, so I'm going to take this equation and these potential solutions and recopy them on the next page. So we've got the square root of 2a minus 3 plus 3 equals a, and a is 6, a is 2. Let's take the 6 and check our work with that. So we'd have the square root of 2 times 6 minus 3 plus 3 equals 6. The square root of 12 minus 3 plus 3 equals 6. The square root of 9 plus 3 equals 6. 3 plus 3 equals 6. 6 equals 6. So the first one checks. Let's take a equals 2 and plug it in. The square root of 2 times 2 minus 3 plus 3 equals 2. The square root of 4 minus 3 plus 3 equals 2. The square root of 1 plus 3 equals 2. 1 plus 3 equals 2. 4 equals 2. So this is, let's see here if I can spell extraneous here. Extraneous. So extraneous. So that has no solution. This, not okay. It does have this solution, but this one doesn't work. So this would be an extraneous solution, meaning it doesn't work. This would be the only correct solution. All right, with that, Okay, let's take a look at this example. The square root of 3x plus 5 equals 2. So we have one radical in this equation. So we'll isolate the radical first by subtracting 5 from both sides. We get the square root of 3x equals -3. So now we've isolated the radical term. It's a square root, so we'll square both sides of the equation. On the left side of the equation, we get 3x. On the right side of the equation, we get 9. Solving for x, we'll divide both sides by 3. X equals 3. Let's check our work. The square root of 3 times 3 plus 5 equals 2. The square root of 9 plus 5 equals 2. 3 plus 5 equals 2. 8 does not equal 2. So the solution is not correct. There is no solution. So this would be an extraneous solution, but it does not work. There's no solution. Now, let's go back to the beginning of this problem. And the first thing that I did was to subtract 5 from both sides, which gave me this. Let's review some rules. You can't take an even root of a negative number and get a real solution. When you do take an even root of a positive or zero number, you can't get a negative solution. Well, that's what we're trying to get right there. We're saying the square root of something is a negative number. So right there is a sign that, oh, this is not going to work. Okay, so there's no solution. Okay, let's see here. Let's take a look at this one. The cube root of 7n minus 1 equals 3. So I've got one radical and it is isolated, but it's a cube root. So now I'm going to cube both sides. The cube root of 7n minus 1, the quantity cubed, becomes 7n minus 1 because the cube root and the cube undo each other. On the right side, 3 cubed is 27. So here's our equation without the radical. I'm going to add 1 to both sides. So I get 7n equals 28. I'm going to divide both sides by 7. N equals 4. And let's check our work. 7 times 4 is 28. 28 minus 1 is 27. The cube root of 27 is 3. 3 equals 3. So the solution checks. N equals 4. Any questions about that problem? Okay, let's take a look at this one. Let's see here. We have x cubed plus 56 to the 1/3 power equals x plus 2. So 1/3 power is the same thing as cube root. So what am I going to do? I'm going to cube both sides. A power raised to a power, you multiply the exponents, right? 1/3 times 3 is 1. So the quantity x cubed plus 56 to the 1/3 power, and then the whole thing cubed becomes x cubed plus 56. We okay with where I got that on the left side of the equal sign?
Can you please explain it, how you got it?
Okay, there's a rule that says, let's see here, a power raised to a power, you multiply the exponents. So like x squared cubed becomes x to the 6th power. Well, what would x to the 1/2 power squared be? It'd be x to the 2/2, or x to the 1, or just x. You followed that?
Yes.
So that's what I did here. I had something to the 1/3 power, that whole thing cubed, but 1/3 times 3 is 1. So we get x cubed plus 56 to the 3/3 or the 1 power.
Oh, thank you.
You got it?
Yes.
Okay. Now on the right side, I've got a mess here. I'm going to need some room, so I'm going to erase all this stuff here. We've got x plus 2 times x plus 2 times x plus 2, because we've got 3 factors of x plus 2. Okay. So I'm going to FOIL together the first two, x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4 times x plus 2, and then foiling x cubed plus 2x squared plus 4x squared plus 8x plus 4x plus 8, which is x cubed plus 6x squared plus 12x plus 8. And that's all going to go over here. Antonia, can you turn your mic back off, please? Thanks. Just noise was coming through there. All right. But if you have a question, certainly turn it back on. All right. So x cubed plus 56 on the left, and then that whole big thing on the right after multiplying x plus 2 times itself. Well, this is a 3rd degree equation. I'm going to put everything over on the right. So I'm going to subtract x cubed from both sides. But when I do that, now I've got 56 equals 6x squared plus 12x plus 8. So now it's a 2nd degree equation. I still want everything on one side. So I'll subtract 56 from both sides. And I get 0 equals 6x squared plus 12x minus 48. Yeah. Now, 2nd degree equation, I'm going to solve it by factoring. But the first thing I can do is take out a 6 as the greatest common factor. And then factoring further, let's see, this is going to be a plus 4 and a minus 2. Okay. So 6 equals 6, but x plus 4 equals 0, x minus 2 equals 0. If x plus 4 equals 0, subtract 4 from both sides and we get x equals -4. If x minus 2 equals 0, add 2 to both sides and we get x equals 2. All right, so let's go back and recopy the original equation and the potential solutions to see if they work where I have some room. But before we do that, do you need to write anything down before I switch screens? Should I hold up here for a minute? Okay, so we're good to go. All right, on the next page, we've got x cubed plus 56 to the 1/3 power equals x plus 2. And our solutions are x equals -4, x equals 2. I think I've got everything correct now. So let's check our work. Let's take the -4. -4 times -4 is positive 16, times -4 is -64. -4 plus 2 is -2. -64 plus 56 would be -8. The cube root of -8 is -2, so that checks. So that checks. Let's try the other solution, x equals 2. 2 cubed plus 56 to the 1/3 power equals 2 plus 2. 8 plus 56 to the 1/3 power equals 4. 64 to the 1/3 power equals 4. The cube root of 64 is 4. 4 equals 4. It checks. So both solutions are correct. All righty. What about a situation where we have an equation with two radicals in it, like the following? Well, if we have two radicals in the same equation, we want to separate them, one on each side of the equation. This is already in that form. So now I'm going to come back and square both sides of the equation. On the left, I get 3x plus 12. On the right, I get 5x minus 12. It's a first degree equation. I'll put all the x's on the left. So I'll subtract 5x from both sides of the equation. Negative 2x plus 12 equals negative 12. I'll subtract 12 from both sides of the equation. Negative 2x equals, negative 24. Divide both sides by negative 2x equals 12. Let's check our work there. Let's see, if x is 12, got the square root of 3 times 12 plus 12 equals the square root of 5 times 12 minus 12. 3 times 12 is 36. 36 plus 12 is 48. So we've got the square root of 48. 5 times 12 is 60. 60 minus 12 is 48. Well, the square root of 48 equals the square root of 48. I can see that without having to simplify anything. So that solution works. Now, it's possible to get two radicals in the same equation and another term, and then things get a little bit tricky. We're not going to go there, so you don't need to worry about that situation. Maybe we'll save that for a Math 141 class or something. All right, now let's take a look at some formulas. The following formula says V equals the square root of 2gh, and we are to solve for h. Well, h is locked up inside of a radical, inside a square root. So we need to get rid of the radical. The radical is isolated. We'll square both sides. On the left, we get v squared. On the right, we get 2gh. If we divide both sides by 2g, we get v squared over 2g equals h. And we've solved for h. Any questions about that example? All right. Suppose we've got d equals 1.4 square roots of h. Solve for h. Well, there's just one radical term and it's isolated. It does have a multiplier, the 1.4 outside. We can get rid of it first or later, either way. If we get rid of it first, we would divide both sides by 1.4. So then we'd have d over 1.4 equals the square root of h. But we want h, not the square root of h. So now we'll square both sides. We get d squared over 1.96 equals h. Because I believe 1.4 times 1.4 is 1.96. 1.4 squared is 1.96. Yes. All right. Now, we could also do this problem not removing the 1.4 yet. In that case, we would square both sides. We'd get d squared equals 1.4 squared square root of h squared, because we have a product raised to a power. You get 1.96h, divide both sides by 1.96, and we get the exact same answer as we got before. So either way. Any questions about that example? All right, let's take a look at this formula. D equals the cube root of 12v over pi. This is supposed to be a v, doesn't look like a v. Okay, solve for v. V is locked up inside of a cube, so I'm going to cube both sides first. On the left, I get d cubed. On the right, I get 12v over pi. I'm going to multiply both sides by pi. So now I've got pi d cubed equals 12v. Divide both sides by 12. V equals pi d cubed over 12. Any questions there? All right. It says R equals the cube root of quantity A divided by P, and then minus 1 outside of the radical, and we're to solve for P. So first of all, let's isolate that radical by adding 1 to both sides of the equation. So we get this. Then we're going to cube both sides. So on the left, I've got R plus 1 cubed, and on the right, I've got A over P. I need to solve for P. I need P on top. P is on the bottom. I'm going to multiply both sides times P. So I get P times R plus 1 cubed equals A. But I need P by itself. So I'll divide both sides by R plus 1 cubed. Let's try that again. By R plus 1 cubed. Still didn't make it. Third time's a charm. So now I get what? I get P equals A over R plus 1, the quantity cubed. I remember the first time I did this problem, I multiplied all of this out, and then the author didn't even bother to. I guess we kind of needed to in a problem we did way back when to solve for a variable, but in this case, we can just leave it to solve for P. Okay. How about this one? We've got m to the 4th power plus, plus m squared minus 25 all to the 1/4 power equals m. So I've got a 4th root radical term. It's written as a fractional exponent, but it's the same thing. I'm going to raise both sides to the 4th power. So m to the 4th plus m squared minus 25, the whole thing to the 1/4 power, and then that whole thing to the 4th power. We multiply the exponents together, which becomes a 1, and so we get that, and on the right we get m to the 4th power. Any questions about that? Okay, I'm going to subtract m to the 4th from both sides. So now I've got m squared minus 25 equals 0. That's the difference of 2 squares. So m equals -5, m equals +5. Let's check our work. So we'll put -5 in. -5, the quantity to the 4th power, plus -5, the quantity squared, minus 25, the whole thing to the 1/4 power equals -5. Now let's see here. -5 to the 4th power, -5 times -5 times -5 times -5 is 625. -5 to the 2nd power, -5 times -5 is 25. And those are going to reduce down. So we're going to have 625 to the 1/4 power equals -5. The 4th root of 625 is a +5. So that's not going to work. Let's try the +5 for m and plug that in. +5 to the 4th plus +5 squared minus 25 to the 1/4 power equals 5. 625 plus 25 minus 25 to the 1/4 power equals 5. 625 to the 1/4 power equals 5. 5 equals 5. It checks. So two potential solutions. This one's extraneous. It doesn't work. This one is correct. Any questions about that? Okay. Let's take a look at this problem. Let's see here. F of x equal the 4th root of the quantity x plus 8 minus the 4th root of 2x. Find all values of x for which f of x equals 0. So basically what we're going to do is we're going to substitute that over here, and we're going to have the following equation. Okay. Now, I can add the 4th root of 2x to both sides. And I now have the following equation, which just has a radical on each side of the equation. Okay. I can raise both sides to the 4th power. The 4th powers will cross out or get rid of the 4th roots. So I end up with 2x equals x plus 8. Subtract x from both sides, x equals 8. Let's check our work. 0 equals 4th root of 8 plus 8 minus the 4th root of 2 times 8. 0 equals the 4th root of 16 minus the 4th root of 16. Well, the 4th root of 16 is real. It's actually 2, and 2 minus 2 is 0. So 0 equals 0. It checks. All righty. Well, that's all I've got for you today. So again, tonight, wrap up your homework from this chapter, section 9.5, as well as the chapter review. I will be back at 1:15 with an office hour. Tomorrow during class, we will review, and then Wednesday, there'll be no regular class meeting as we'll be taking our chapter 9 test. All righty. With that, I'm going to stop the recording. I can find the mouse here. Here we go.